Welcome, my name's Doctor Warrick Bishop. I'm a cardiologist, I'm an author and a keynote speaker. I'm CEO of the Healthy Heart Network. I'm all about trying to help people live as well as possible for as long as possible. Heart disease is huge in Australia. Every 20 minutes someone suffers a heart attack. Most of these could probably have been avoided if only we knew what to do. This podcast is all about helping you understand blood pressure, weight, cholesterol for better health. If you enjoy this podcast, I would be honoured for a 5-star review. You can share it with your family and friends. It may well save someone you love. Hi, my name's Warrick Bishop and welcome to my podcast and videocast station. Today I'd literally like to chew the fat. Well, an article that came past me just the other day was talking about brown fat. Now, you may or may not know much about fat, but it turns out that there are two different types of fat. There is what is called white fat, and there is what is called brown fat. Well, it turns out that white fat is a misnomer anyway. It's actually yellowish, and brown fat is quite dark and red. So brown would be a reasonable terminology for it. Well, if we've got two different types of fat, is that because they've got two different actions? Well, to a large degree, white fat, which is the stuff around our tummies that we accumulate if we've eaten too many calories, is really a very powerful energy store. So white fat is our energy reserve, and things like insulin drive triglycerides and other fats into the white fat cells, the adipose tissue, for storage for use later on. It turns out that white fat of its own, however, can cause all sorts of problems. It can have its own, if you like, metabolic action, and that metabolic action is problematic because it can drive inflammation and drive insulin resistance if you have too much white fat. Well, that then begs the question, what's brown fat about and where does that tend to hang out? Well, brown fat is characteristically associated with young mammals. Think babies, or think baby anything for that matter. And brown fat tends to accumulate around the upper part of the chest and back, particularly across the back. Now, brown fat appears to be very important for thermoregulation for these young mammals. Again, think a baby or a child. Children have a much greater surface area than adults, and therefore they're much more subject to cold and therefore loss of heat and therefore energy. It turns out that brown fat can burn energy in what's called non-shivering thermogenesis. Well, what does that mean? It means basically that this brown fat can become metabolically active and generate heat. Non-shivering means, of course, you're not shaking and your muscles are not twitching, and thermo means heat, genesis means creation. So non-shivering thermogenesis, brown fat literally metabolizing to generate heat and keep that baby warm. Well, how does all that work? Well, it turns out that there's a protein called mitochondria uncoupling protein 1. Mitochondria uncoupling protein 1. If you're a scientist, you could call it UCP1. Well, it turns out that this mitochondrial uncoupling protein 1, in the presence of fatty acid, leads to leaking of protons across the mitochondrial membrane. And this seems to short-circuit the mitochondria to produce heat by passing the ATP synthesis pathways. Now, this is all pretty heavy, but the long and the short of it is our mitochondria are normally producing ATP, adenosine triphosphate. This is our energy unit within those cells of our bodies, and the mitochondria, if you like, are the energy cells within our normal cells. the mitochondria produce ATP so the rest of the cell can function. Well, if mitochondrial uncoupling protein can bypass that ATP process, it seems that the mitochondria can then produce heat instead. And it seems that there is some sort of purine derivative, another chemical compound that can block that action. We all actually have a little bit of the old brown fat. We hold on to some even as we get older. So scientists are starting to look at whether they can block that purine interference of the mitochondrial uncoupling protein 1 so that brown fat can literally metabolize more effectively, bypass ATP metabolism, but generate heat and therefore burn energy. Well, why would that be important? Well, it could be a very important way to reduce total energy content for an individual, and burning off energy could literally be burning off fat. Interestingly, brown fat, the better it works, the more glucose it releases from the bloodstream. So there's every chance that we may see in the future therapeutic targeting to block the purine process that blocks mitochondrial uncoupling protein 1 so that our mitochondria can short circuit the ATP synthesis process and generate non-shivering thermogenesis to burn energy and therefore be burning calories and therefore potentially as a weight loss intervention. How interesting is that? Well, if anyone is interested, there's lots of stuff on the internet about brown fat and trying to trigger it. And how could you do that? Well, it turns out that cold might be able to do it. So lots of people are talking about cold baths, cold showers, walking around in cold weather in a t-shirt. All this can also stimulate your brown fat to burn energy. And as a small benefit, the cold stimulus can trigger what's called cold shock proteins, which are within the tissues and are activated through that cold stress, increasing metabolism. So white fat, brown fat, non-shivering, thermogenesis, a chance to trigger possible calorie consumption and therefore reduce weight, an incredibly interesting target in the future for therapeutic intervention. But for now, maybe take a cold shower and see how you go. I hope you found that interesting. I hope you like chewing the fat, just like I do. I'm going to wish you the very best. I hope you live as well as possible, for as long as possible. Take care, and bye for now. Did you know that coronary artery disease kills 1 in 4 people? So most of us are likely to carry some risk or know someone who does. If you're interested in finding out more about how to evaluate that risk, check out www.virtualheartcheck.com.au. It'll give you information about risk and what else can be done to be even more precise.